Thanks for joining me this afternoon. My name is Mike Fitz, and I'm a park ranger here at Katmai National Park and Preserve. And this afternoon, I wanted to talk to you about the Valley of 10,000 Smokes, which is actually a really sort of fantastic landscape and unique landscape on the face of the earth. So this hangout's going to be in two parts, basically. The first part of the hangout is going to be sort of an introduction and a short program on the Valley of 10,000 Smokes. So I'll be talking about the area's geology, some of the history associated with the Valley of 10,000 Smokes. And after that, I'm going to try to take as many questions as I can about the valley and do my best to try to answer those. And then the second part of the hangout is going to be me also answering questions and talking about the logistics of visiting the Valley of 10,000 Smokes. Here at Katmai National Park, we do have a bus tour that goes to the valley, and if you want to join that, you can do that every day during the summer, and I'll give you more details on that in the second part of the hangout. And I'll also try to talk about the logistics of exploring the Valley of 10,000 Smokes on a backcountry trip if you wanted to do that as well. So if you have questions about those things or anything associated with the Valley of 10,000 Smokes, again, I'll do my best to try to answer those. So please post those in the Q&A app. That's, if you're watching this on Google+, you can find that on the screen. So please post your questions there, and I'll do my best to try to answer those. One thing to remember, though, is try not to use that Q&A section as a chat window, because sometimes the questions tend to get lost in there. So that's just something to be aware of as well. So without any further delay, let me share a screen with you. I have a bunch of things that I'm going to be doing at the same time. So if you find my eyes, sort of wandering around, that's because I'm trying to look at different parts of the screen at the same time. I'm trying to find questions. I have an iPad next to me right over here where I'm going to be taking a look at some of my references if need be, and also trying to answer those questions as best I can. And I have some props around here too that I'll try to show everybody and talk in the part of the program where they're most relevant. So please bear with me if you find me wandering around. So let me share a screen with everybody, and we'll get started here with our hangout about the Valley of 10,000 Smokes. So I'm going to have to share my desktop with everybody, so just hang tight for just a second here. All right, and I'm going to play this little keynote presentation for you. So, I think the Valley of 10,000 Smokes is really sort of a unique landscape on the face of the earth. I don't know of anything that's quite like it. It's a spectacular landscape in a lot of different ways. It was formed within a matter of hours on June 6th, 1912. And it's a landscape that's really not well known across the face of the earth. Unless you're a real volcano geek, then you may have heard of the Valley of 10,000 Smokes. But a lot of people don't, and that's okay. It's in such a remote place here on the Alaska Peninsula that it's difficult to get to, it's difficult to explore. But definitely it's worthwhile seeing if you have that opportunity. But since I know most of you can't get to the Valley of 10,000 Smokes, I'm going to try to bring that to you. However, we should really ask ourselves, well, why is it such a unique and why is it such a special place? So for a moment, let me indulge you, and let's step back in time to the morning of June 6th, 1912. So, for example, on June 6, 1912, it actually was a very clear day across the Katmai region. People on Kodiak Island in the village of Kodiak, they were just waking up to our normal Thursday morning, going about their business, not necessarily thinking that this day was going to be really any different from the last day or the day before. It was just going to be an ordinary day here on Kodiak Island. If you were out sailing on a steamship called the Dora out in the Shelikof Strait, you actually probably would have remarked on how fine the weather was. In fact, the captain that day did remark that in the Shelikof Strait that day that the weather was just spectacular. Beautiful clear weather for sailing across one of the really roughest stretches of water on the world. And if you were on the Pacific coast of Katmai, or even in the interior of Katmai, and some of the native villages there, like at Douglas, or working in Kaflia Bay, or at Savanoski Village, which this is a photo of Savanoski Village here, you would have also been going about your business. People on the coast were actually smoking fish to sell, as well as drying it for their own use. But a lot of people did realize that there was something different that week. Earthquakes in the Katmai region had been increasing in frequency and intensity for several days. The sunny and calm weather, it really didn't reflect the unsettled earth. And people in this region wouldn't see really much daylight at all for the next 3 days. And one person actually described the next 3 days as being sort of hellacious conditions. In Kodiak Village, people were so panicked by the volcanic eruption that was occurring that nearly 500 people gathered onto one steamship, thinking that maybe they were going to have to run out to sea to escape the falling ashes. They didn't know if they were going to be buried under ash. Upwards of a foot of ash actually fell in Kodiak Village, which is about 100 miles downwind of the eruption itself. And people on the coast of Katmai National Park, the modern-day Katmai National Park, they didn't fare any better. In fact, they may have fared even worse, because in some places on the coast of Katmai, nearly 3 feet of ash fell on the level. So really, what could turn such a beautiful day into such a nightmare? A lot of towns and villages in the area were permanently abandoned due to some catastrophic event that happened really not without warning, but without a lot of warning. And of course, this was in a time period where people didn't understand volcanic eruptions very well. They didn't understand the mechanisms that caused them. So people were suffering. It was a very destructive event. However, it was also an event that perhaps maybe destroyed landscapes and altered them in a lot of different ways, but it also created landscapes in a lot of different ways. Turned a remote glacial lake valley into a steaming inferno, but this was really the same event in the same landscape that not only displaced people, but caused other people several years later to become sort of overawed, quote-unquote overawed, by what they happened to see. It was a landscape that, of course, attracted scientists. It was a landscape that had incredible destructive power, causing the summit of Mount Katmai to collapse, leaving a 2,000-foot caldera underneath. And it was an event that really, even today, still attracts scientists, curiosity seekers, and explorers. And this event, this volcanic eruption that happened here on June 6, 1912, creating the Valley of 10,000 Smokes, was an event that really demonstrates the Earth's power to destroy and create. So really, what happened here in 1912? What was happening to cause such a destructive and creative change? Now, when you picture the volcanic eruption that happened here at Katmai, don't picture a Hawaiian eruption. There are many different types of volcanic eruptions that geologists have described. Some of the most famous happen to be Hawaiian eruptions, where sometimes you do have large fountaining events, but also many lava flows. And these are relatively safe volcanic eruptions for you to actually view from a distance, of course. Similar to Hawaiian eruptions are also Strombolian eruptions. There are a few others too. There's Vulcanian eruptions, there's Surtsian eruptions. But the eruption that was happening here in Katmai on June 6, 1912 certainly wasn't an eruption that you could view up close and personal safely, like you can with some of the events that happen on Hawaii. What was happening at that time was a Plinian eruption. So the steamship I mentioned at the very sort of beginning of the slideshow here, the Dora, they were out in Shelikof Strait, and they were sailing under fine, clear weather, but they ended up sighting an eruption column about 1 p.m., and they took a bearing on it, and they saw that it came from the Mount Katmai vicinity. Really what they were seeing was a giant ash cloud moving up into the sky. And this eruption, like many of the other very powerful catastrophic eruptions around the world, are called Plinian eruptions. They're really defined by very voluminous eruptions that happen to generate a lot of ash, and that ash is generally sent up very high into the atmosphere. With the Katmai eruption, it was about 20 miles up into the atmosphere is where this ash eventually went. And this photograph right here is from Mount Redoubt in 1989. But plenty of eruptions. That's what happens with a lot of volcanoes in Alaska when they happen to erupt very explosively in these large-scale eruptions. And Mount St. Helens in 1980, Mount Pinatubo in 1991, and also Krakatoa volcano in 1883. Those were all plenty of eruptions. So this is actually a picture from the Dora on the afternoon of June 6, 1912, and the sort of dark gray skies at the top are the ash cloud that happens to be approaching them. And of course, by 5 p.m., ash began to fall on Kodiak Island, and even closer to the eruptive center, the situation was much, much worse. You know, if you're on Kodiak Island, you're about 100 miles downwind of the eruption. You're getting a lot of ash, but you're not necessarily in danger of your life. The people at the time in Kodiak, they didn't know that. They didn't know how much ash was going to fall, of course. But even closer to the eruptive center, there was a lot going on. And to sort of explain to you, just there I am again, so I'm back on the screen. Kind of to try to demonstrate just how violent this eruption was, I'm going to try to show you a couple of different rocks here. So bear with me one moment. I'm going to have to get some props along the way because I have a piece of and I'll hold it up to the screen here so you can see it. So I have a piece of granite right here. And if you've ever held a piece of granite, you know these are pretty hard rocks, very dense rocks. When you take a real close look at it, you can see that there are individual minerals in here that are very easy to see. So granite is a very hard, very dense rock. Happens to form underneath the surface of the Earth over several 100,000, or sometimes even you know, 1,000,000 years or more with some of this. Now that piece of granite, I want you to we're going to compare it with another rock that I have, and this is just a piece of pumice from the 1912 eruption, and this pumice is a piece of rhyolite. Rhyolite's a lava that erupts on the surface of the Earth. It's the same stuff that makes up obsidian, if you're familiar with that rock, that is great for flint knapping and making weapons out of. So this rock right here, this piece of rhyolite, looks different, feels different in a lot of different ways. But there's something, and the differences between these two rocks we can use to really demonstrate how violent this eruption is. Now to do that, I have to get something else. So I have a jar of water here, and in the bottom of it is some paper towels, because this is the glass bottle. I'm going to drop some rocks in here, and I don't want to break it. So that's just something to be aware of. So I'm going to take my piece of granite here. I'm going to drop it into this bucket of water, and of course it sinks. You know, that's no surprise to anybody. I'm going to take my piece of rhyolite. I'm going to take that. I'm going to put it in the water as well, and you can see that floats. Pumice is a rock that is less dense than water, so it floats. And if you want to know if you're holding pumice in your hand, throw it into a bucket of water or a puddle or something like that, and if it happens to float, you know that you're holding pumice. And these two rocks, I mean, they look very different. They're different physically in many different ways. You take a look at the rhyolite, and you can't actually see any minerals inside of it, inside of this pumice. And of course, it floats on water, and that hunk of granite's certainly not going to do that. But these two rocks actually are identical chemically. So really, the only difference between these two rocks happens to be at the rate that they cooled. One, that piece of granite cooled underneath the surface of the Earth over very, very long periods of time. The piece of pumice, however, happened to cool as it was being erupted. Oops, I'm dripping water on my computer here, which is kind of a no-no. So bear with me for a moment. This piece of rhyolite cooled on the surface of the Earth very quickly as it was violently being erupted. out of a volcano. And that's what was happening here on June 6, 1912. Magma actually contains a lot of dissolved gases, and including water as well. So when everything's underneath the surface of the Earth, it's sort of all hunky-dory. It's a dynamic equilibrium, but as long as the pressure is confining the magma, it's also confining the dissolved volatile gases that are within it as well. It's not only water, but it's also carbon dioxide. It's also sulfur dioxide and a bunch of other things. But when the pressure is released, it's like taking your lid off your pressure cooker, and everything flashes into steam. So that water, it basically just comes out of solution, and as it does so, and the magma ascends to the surface, it sort of just rips the rock to shreds, just destroys it. And as the rock is being thrown into the air, it's being fragmented. It goes up into way up high into the atmosphere as the ash that rains down in the sky. Some of the larger chunks don't get fragmented as much, but they're filled with vesicles. They're filled with air pockets. So it can make the rock not very dense at all. In fact, with the demonstration I showed you, this will float on water. But I think when you take a look at rhyolite and compare it to and rhyolitic pumice especially, and you compare it to a piece of granite, and you see just how different they are physically, but when you analyze it chemically, you see that they're exactly the same. I think that really illustrates how violent these Plinian eruptions happen to be, and that was, again, what was going on here June 6th through June 9th, 1912. So for 60 hours, this volcano happened to be erupting quite violently. So there was other stuff that was being ejected out of the ground at the same time. And let me show you another piece of pumice before we go back to our slideshow for just a moment. And that's a piece of banded pumice. So this is actually going to be key to sort of understanding what was happening here on June 6, 1912. Different magmas were interacting underneath the surface of the Earth here at Katmai within really a matter of hours before the eruption happened. And these bands correspond to different types of lava that were erupted on the surface of the Earth. So you have a little bit of andesite, a little bit of dacite, a lot of rhyolite that happened to come out of this eruption too. And the differences between these different types of lava in this piece of pumice also happen on the microscopic level. So there was really not a lot of mixing going on at that time. So that's key to understanding the eruption, and I wanted to throw that in there so we get back to our slideshow here. And let's see, let me share that screen, the desktop with you one more time. Okay. So we're back to our slideshow now, because again, you didn't just have stuff being thrown up into the atmosphere, but you also had stuff falling onto the ground, and actually there was so much ash in one valley in particular that it was filling it up with several hundred feet of ash near the eruptive center itself. And we don't really know what the Valley of 10,000 Smokes looked like prior to 1912 because there's really no photographs of it, but we have a kind of an idea that there was braided streams running through it, probably had tundra vegetation at the head of the valley. Towards the lower end of the valley, it would have transitioned out of that tundra and into a shrubby habitat where you have a lot of willows, a lot of alders, and there was glacial streams that happened to be flowing through it. But there was so much ash going up into the atmosphere that a lot of times the ash column was sort of collapsing on itself. So when it was doing that, it was creating these things called pyroclastic flows. And this is a photo of a volcano in the Philippines that's erupting. And on it, you can see these ash clouds coming down the slope of the volcano, and those are pyroclastic flows. Many of these happened during the 60-hour eruption here. And these pyroclastic flows are just devastating forces. They can sometimes travel at 100 miles an hour. They can be very, very hot, of course, because they contain a lot of molten material. Really, just very destructive, a very destructive force. And we had this giant ash cloud flying up into the sky, and people on Kodiak Island thinking they were going to be buried. An area was being buried, and it was the Yucak River Valley. In fact, 45 square miles of land was buried underneath these pyroclastic flows. And when you are looking at whoops, sorry here, clicked on the wrong button. Let me go back. So when you are actually looking at the Valley of 10,000 Smokes, and this is an enhanced satellite image, in the center of the screen, sort of that lobe of brown that just oozes out in between some mountains, that's the Valley of 10,000 Smokes, and those are that is all pyroclastic flows and surges that came out during that 60-hour eruption. So quite incredible amount of material that they came out of the Earth. So, but I should digress a little bit because there was also something else going on at that time too. Just wasn't pyroclastic flows that were filling valleys, but there was also a mountain collapsing at the same time. Mount Katmai was probably about 7,500 feet in elevation at its summit prior to June 6, 1912. But after June 6, 1912, there wasn't a summit there at all. The mountain had just seemed to implode. It just essentially it collapsed in on itself. Many early explorers into the area did think that the mountain had exploded, and we now know that's not quite what happened, although there was just a little bit of material that did come out of Mount Katmai during this eruption. But what we found instead, even though there's this 2,000-foot caldera that was formed during the eruption, we found instead that through later geological investigations that almost all of the ash that went into the sky, all of the pyroclastic flows that filled the Valley of 10,000 Smokes came from this relatively tiny lava dome, or a spot at the lava dome that today is called Nova Rupta. So you have this blob in the middle of the photograph, and that's the Nova Rupta lava dome. You can't quite tell how big it is in this photograph, but it's about a half-mile in circumference. It's about 200 feet tall. It's a sort of a really spectacular place to visit, and if you are taking a backcountry trip, into the Valley of 10,000 Smokes, I'd highly recommend that you go see the Nova Rupta lava dome. It's definitely worthwhile. So what was happening at that time is that Nova Rupta and the vent around Nova Rupta was draining the magma from underneath Mount Katmai. And as it did so, Mount Katmai just couldn't hold its top up anymore. The magma had drained from underneath it, and it just collapsed in on itself. And during the eruption itself, there were many magnitude 6 to 7 earthquakes, I think upwards of a dozen or more. And those earthquakes, many of them corresponded probably with the collapse of the summit of Mount Katmai. You can imagine Mount Katmai losing several thousand feet of its summit, and that's going to cause some very strong earthquakes, and people felt those across the region, and those were recorded in the few seismometers that were active in North America at the time. So finally the ash did happen to stop. The ash stopped falling on Kodiak Island on June 9th at dawn, really. This was a really extraordinary event within historic times. The eruption itself, it lasted for 60 hours. It released a great volume of magma. 13 cubic kilometers of magma came out of the earth. That's about 3 cubic miles of material. And that, when it was being erupted out of the earth, expanded 3 times its original volume. So you had about 45 cubic kilometers of material falling across the earth. This was one of the 5 largest eruptions in recorded history. Ashfall from this eruption was global. There was an aerosol dust that was reported as far away as the Mediterranean region. Surrounding Nova Rupta itself, ash deposits on the former surface of the Earth are thought to be several hundred feet thick. And pyroclastic flows and surges, like I mentioned before, from the Nova Rupta vent buried 45 square miles of land. Villages at Katmai, Kukak, Douglas, they were all abandoned. Savanoski, they were abandoned permanently. So when we, oops, a little too far ahead of myself, but when we take a look at this eruption and we see just how destructive it is, it might be hard to imagine, to think about how it can create. But volcanoes are not only forces of destruction, but they're also forces of creation as well, too, in a lot of different ways. And one of the ways that this eruption happened to be creative is that, well, it created a legacy of a different sort because it attracted people to the area. It attracted scientists to the area. It attracted explorers to the area. And probably the most famous and influential explorer into this area in the years immediately after the eruption happened to be Robert F. Griggs. So he's on the right of the photograph here with his wife Laura. And he came to Kodiak Island to study actually revegetation of Kodiak Island after the eruption, but he became very curious about what was happening at the eruptive center itself. So he wanted to investigate the Mount Katmai region. Had a hard go at it the first time he went into the area, landed at Katmai Bay, found Katmai Village, what was left of it had actually just been destroyed by a giant flood that had come through the area. And this is the Russian Orthodox Church at Katmai Village. And he noted that the high watermark on this building was at the bell that's just to the right of the building. And this is in a narrow valley that Katmai Village was located in. The valley at that point is, I think, several miles wide. So there was a huge volume of water that was coming through and picking up buildings from Katmai Village and moving them to certain areas. So he had a hard go at it, real hard go trying to get up the Katmai River Valley itself, going through the quicksand, the pumice, and the ash that was there. So he had to come back in 1916. When he came back in 1916, he had better success in getting close to the eruptive center itself. They didn't really know what they were going to discover. But as they were slogging through Katmai Pass, trekking and carrying all of their supplies along with them, going through narrow canyons, having to traverse landslide debris, climbing up and over snowfields that are buried in ash itself. Eventually they came across a landscape that just overwhelmed them with what they described to be such beauty. You can imagine Griggs coming into Katmai Pass for the first time, and he was attracted to Katmai Pass just by seeing a few wisps of steam off on the horizon, and he wanted to know what they were. But he describes, I think quite sort of elegantly in one way, what he saw. He says that the sight that flashed into view was one of the most amazing visions ever beheld by mortal eye. The whole valley, as far as the eye could reach, was full of hundreds, no thousands, literally tens of thousands of smokes curling up from its fissured floor. So he was awestruck by what he happened to see. He wasted all of the film that he had with him that first day trying to get a picture of the landscape itself. But Griggs and his team had discovered the Valley of 10,000 Smokes. And he led many expeditions back into the valley during the late 1910s, and each time he became more and more enamored with it. He also says and wrote in his book in 1922 that our feeling of admiration for the valley soon gave way to one of stupefaction. We were overawed. For a while, we could neither think nor act in a normal fashion. So just being overwhelmed by the beauty that they saw, they found this landscape that had been really destroyed by a volcanic eruption, but also something else was created at the same time. And Griggs thought this was such an amazing place that it was worthy of scientific investigation. It was also worthy of preservation and recreation. But there we are. I need my video to play. So when he was discovered the Valley of 10,000 Smokes, what he was seeing was steam vents. He was seeing fumaroles across the landscape. And what happened in the Valley of 10,000 Smokes is there was so much hot ash that was deposited on the ground that any water that happened to seep into it, or any water that was trapped underneath, maybe in glacial rivers or ponds, or of course any snow drifts that happened to be there at the time, since it was early June and there's typically a lot of snow in that area in early June. This stuff happened to be flashed into steam, and as it was superheated, that steam was being forced out of the earth, and that's really what Griggs was seeing across the landscape. And I think this footage is definitely worthwhile seeing. This was taken by him in I think 1919, but I'd have to double check my fact on that. So again, thousands of smokes across this landscape. And if you've been to Yellowstone today, there are fumaroles in Yellowstone, and I think those will give you kind of a good idea of really what that happens to be like. Everywhere they went, they happened to be able to find fumaroles. And in fact, some of these fumaroles were so hot that they could melt lead. And lead melts at about 600 degrees Fahrenheit or so. But they found that they could easily find many fumaroles that could melt lead. And it's a little bit hard to see in that video, but you can see that lead is just disappearing quite rapidly. So if you ever wanted to know if you could actually melt lead with water, you can, because most of what was coming out of the fumaroles just happened to be water. Now the fumaroles may have cooled since that time, and that was something Griggs didn't think would happen. He didn't think that the fumaroles were going to cool. He thought they were a perpetual landscape. But they did cool over time. You get that much water flowing into the ash, and eventually it is going to cool. The ash is just going to dissipate that heat. But the valley is still a very amazing landscape to explore, and very colorful. And you can see remnants of the fumaroles really all across the valley itself, where they're staining on the rock. The fumaroles and the steam and the acids within that were leaching the minerals out from within the ash itself and redepositing, precipitating those minerals as the steam cooled on the surface and couldn't carry those dissolved minerals anymore. And you can find that all across the landscape. And you can even, sometimes if you find these fumarole pipes here and there, you can even see where the fumarole, just exactly where it was. And there happens to be sort of a gradient, a kaleidoscope of color around these fumaroles, depending on the conditions of the acid that was in the steam, the temperature of the steam as well, and how many minerals could actually carry along with it. So, of course, even though this was a very destructive event, and you a lot of times think that creation and destruction are opposing forces. I mean, this eruption really ended up doing both. By investigating the eruption and its impacts on the land, and remembering the emotions of the people who experienced this place firsthand, we are easily reminded of the eruption's destructive power. Yet there's this other legacy. It's one of creation, certainly. The Valley of 10,000 Smokes inspired people like Robert F. Griggs, and largely through his work and the work of the National Geographic Society, who happened to fund the expeditions into the valley, we have a Katmai National Park here today. 1918 was the year Katmai National Monument was established, and it wasn't established for bears, it wasn't established for salmon, it wasn't established for a lot of the things that we come to think of when we think of Katmai today. It was established to protect this very unique and special volcanic landscape. So it inspired people to create something out of what seemed to be a very catastrophic event. So every time I go to the valley, I'm really reminded of this story. I'm reminded of the violence of this eruption. I'm also reminded of the Earth's power to create and destroy at the same time. So that's a little bit about the Valley of 10,000 Smokes. Oh, I guess I should have checked my Q&A app. So let's see. Were you just seeing my face the whole time, or no pictures at all? Just a talking head. That's kind of boring. So I apologize for that if that actually was the case. So let me try the screen share one more time. I'm not sure why that worked. It seemed to work for me earlier in the day. If you're still watching, and I'll try to go through this quite quickly. Here we are. Okay, so I'm going to go back just to show you the couple of videos. And again, I apologize for the technical difficulties. I don't have anyone else here at Katmai watching this at the time, so no one came rushing over and happened to inform me of that. This is also on Katmai National Park and Preserve's YouTube channel. So if you wanted to watch the whole sort of 10-minute segment of this historic footage, you can certainly do that. Okay, so as you can see, panning across the landscape here, all of the fumaroles, thousands of them across that landscape itself. And again, here's the video of the bar of lead. So again, lead melts at about 1,200 degrees Fahrenheit. Or excuse me, 600 degrees Fahrenheit. But they did find fumaroles that were well above that, double that number. Okay, so again, I apologize for not just having my talking head there for just a little bit. One of the and I'm back again, so you're gonna have to look at me for just a little bit longer. Kind of one of the disadvantages of doing programs on the internet is you can make a fool of yourself for the world. So that's okay. That's what I did. So at least you got a little bit of information about the Valley of 10,000 Smokes. And what I'm going to try to do now is just answer a few of the questions that I see on my screen here. So we're going to try to go through a few of those. And I got a few of these before we happened to start the Hangout. And one of them happens to be, what, if any, plant life happens to grow in the Valley of 10,000 Smokes? So I'm going to try to answer that question now. I have another keynote presentation here, and I'm going to do a screen share in the way that it actually works. So bear with me, you're not going to get the full screen version of it. Let's see, whoops, and that's not the right one either. So let me find it for everybody here. Here we are. Okay. Okay. So the Valley of 10,000 Smokes itself, I mean, it's a very barren landscape. In many places, there's no vegetative recovery at all, even 100 years after the eruption. And this contrasts with even Mount St. Helens, that that erupted in 1980, and much of that landscape was devastated during that eruption. But you see that there's a lot of vegetation recovering around Mount St. Helens. The growing season down there is much longer. It's sort of a more productive climate and ecosystem in a lot of different ways. Near the eruptive center here in the Valley of 10,000 Smokes, near Nova Erupta especially, there really wasn't any vegetation to begin with, to speak of. I mean, at that elevation, about 3,000 feet in elevation in Katmai, you don't really find much vegetation. You find some tundra plants, some very low-growing, ground-hugging shrubs, but you don't find really much of anything at all. In parts of the Valley of 10,000 Smokes, though, you will find the land starting to come back. You'll find that there's a lot of cryptobiotic soil on the surface of the earth, and that's a combination of fungus, mosses, lichens, cyanobacteria. There's a ton of different stuff that's forming this crust on the surface of the Earth, and that lets other plants establish a foothold as well. You'll find some low-growing, very hardy willows in certain places. You'll find even plants with more conspicuous blossoms, like alpine azalea, partridge foot, and perhaps even some dwarf fireweed as well. And you also find vegetation recovering on the edge of the valley too. You'll find it in areas where the ash has washed away down to the sandstone and siltstone that's underneath the ash layer itself. You'll find the vegetation recovering, but on the ash itself, it's really, really hard for plants to get established. Not only because the ash is very low in nutrients, but also because it doesn't retain water very well, and tends to blow around quite a lot. More protected areas and warmer areas, even near Nova Rupta, where you happen to find well, maybe some steam heat still coming out of the earth, some plants have recovered. But out in the middle of the Valley of 10,000 Smokes, where it's really exposed to wind, you find basically nothing growing there, nothing at all. And again, that's because of the nutrient poor conditions. The ash doesn't hold a lot of water, so you have to be pretty tolerant of drying, and especially during dry summers. You also have to be able to withstand the wind, and that's something that is really, really rough on everything that happens to be out there. So you can see the piece of pumice that's prominent on the right side of this photo, and that has been wind scoured by other pieces of pumice that's being thrown through the air. This is close to Katmai Pass, and you can see just, I think this photograph really does illustrate quite dramatically the force of the wind across the landscape. So you can imagine a plant really has a hard time establishing a foothold in that type of environment. So we're not really seeing a lot of vegetation recovery in that area at all. So let's see, a couple other questions here, and this is one that from Anna Marie. Did this eruption affect the Earth's temperature like Krakatoa? And it did. Doesn't seem like it, and I don't really fully understand the processes around this, nor can I really remember all the facts about it either. But it seems like volcanoes that happen closer to the equator, that are on about the size of the Katmai eruption, they tend to have more dramatic effects on the climate. And again, you'd have to look that up. I have to go back into my encyclopedia of volcanoes that I have and try to figure that out. So I can't remember off the top of my head, but it did impact climates worldwide. When you get that much aerosol into the atmosphere, it tends to depress worldwide temperatures for just for periods of time. And the larger the eruption, the longer those climatic effects are going to be. So we ended up having here in from this eruption, I think a temperature drop worldwide for about a year of maybe 0.2 of a degree or something like that. So not super dramatic, but when you get to these very large and cataclysmic eruptions, and there are eruptions on Earth that throughout geologic time that were hundreds of times larger than the Katmai eruption, you can have really large-scale volcanic eruptions. So or really large-scale climatic effects. So that's just something to keep in mind as well. Let's see. There's a few questions on my in the Q&A here that have to do with exploring the valley and let's see, in the logistics of maybe taking a tour and things like that. So I'm going to try to actually answer some of those, and I'm going to try to do the dreaded screen share one more time. So let's see here. We're going to, for the last half of the program here. And again, if you have more questions about exploring the Valley of 10,000 Smokes, please let me know and put it in the queue here, and I'll be happy to try to answer those for you. So we're going to talk about touring the Valley of 10,000 Smokes. So let me bring that screen up here. Okay, so you're seeing that, which is good. So if you want to visit the Valley of 10,000 Smokes, you're coming to Brooks Camp this summer or sometime in the future, there's a tour that leaves every day from Brooks Camp at 9 a.m. And it's an all-day tour, so you leave at 9 a.m., you usually get back around 4:30 p.m. And you get on a four-wheel drive bus, because you do have to cross 3 streams along the way. There's a ranger that happens to accompany you along the way. The first half of the bus ride out really goes through some pretty dense spruce forest. You don't really catch too many views of the surrounding landscape until you get maybe beyond the stream crossings. There are 3 streams to cross, and this is a previous generation of the bus, but it's actually the only one I could find of a bus crossing the streams here. The only bridge actually in Katmai National Park happens to be the floating bridge over the Brooks River. There are 2 overlooks along the way, so you stop at a place where you can look into the iliac arm of Naknek Lake. And for the bear cam fans who are watching right now, if you look in this photograph, on the right side of the photograph, there's kind of a dark line through the trees, and that happens to be Margot Creek, where a lot of bears happen to go in August. Some of the bears from Brooks Camp, that is. One of the other stopping places on the road out gives you your really first glimpses into the Valley of 10,000 Smokes. You kind of see some of the ash flows again, kind of on the right side of the photo, drifting downhill. But eventually you arrive at the Robert F. Griggs Visitor Center, previously, and sometimes it's just sort of nicknamed the Three Forks area, and that's right at the yellow dot itself. And from there, you're greeted really with a spectacular view of the Valley of 10,000 Smokes itself. And sometimes, again, it can be hard to really understand the distances involved when you're seeing a view like this, but Mount Griggs is the tallest mountain that you can see sort of at center left on the horizon. And then you have the Mount Katmai Caldera, which is sort of the low point in the center of the photograph itself. And Mount Katmai is about 16 miles straight line distance from your view there. There's a visitor center there. There's some really great displays along the way. And then after you happen to eat lunch, if you choose to buy lunch with the lodge, you're certainly welcome to bring your own. There's a hike down to the valley floor with the ranger that happens to accompany you. So you get to see the ash up close and personal, at least the edge of it itself. And there are many really interesting things to explore along that route, including the former soil horizon. So that black line through the center of the photograph going, horizontally across the photograph, that's the former soil horizon that was actually charred and carbonized underneath these very, very hot pyroclastic flows. There are a lot of fossils in the exposed bedrock as well, marine fossils that you can take a look at. If you're lucky, you might see a bear. But I wouldn't go on the Valley of 10,000 Smokes tour expecting to see a bear. However, you probably are going to see, or not probably, but you have the opportunity to see a more diverse array of wildlife on the tour than you would at Brooks Camp. I've seen almost every sort of large mammal that Katmai has on the tour, except for caribou. So I haven't seen caribou on the tour, but I've seen wolverines, moose, brown bears, of course, wolves. I think he even saw a coyote from a distance at one time, and we don't really know how many coyotes are in the park, but they are certainly here. So a lot of really, really neat stuff that you can see along the way. Of course, the ranger accompanies you to answer any questions that you have, lead you down the trail to a really sort of violent waterfall. The round trip hike is about 3 miles. You end up descending almost 1,000 feet down to a really mesmerizing but violent waterfall itself. And again, I think one of the real themes associated with or meanings associated with the Valley of 10,000 Smokes is its violence, and that violence still continues today. It's violent winds with the ash and the pumice flying through the air, violent waterfalls as well, violent streams too, and that's something that we'll try to talk about as we can kind of continue through this. So there's been a lot of changes in the Valley of 10,000 Smokes over the past 100 years or so, but it's still a very, very violent place. And I want to talk about, maybe even exploring the backcountry of the Valley of 10,000 Smokes. Octavio actually is kind of wondering, when a visitor takes a bus tour, how much time is there to explore the area? You typically end up having about 3 hours to do the hike for the Valley of 10,000 Smokes. So when you get out to the visitor center, you get there around 10:30 or 11 a.m. You have an early lunch, or you can save your lunch until later if you want to. But you have about 4 hours really to explore. A lot of people end up spending about an hour around the visitor center, leisurely eating their lunch, and then also, of course, listening to a talk by the ranger, getting their questions answered, reading the displays, and then the hike itself takes about 3 hours. So you have about 3 hours on that tour. Now, if you wanted to see anything else out there, and it take more time to explore it, you're certainly welcome to buy a ticket on the bus, get dropped off one day, and then arrange for the bus to pick you up several days later. So if you're into backcountry adventures and you want to explore this landscape, and I try to do that several times per year because I think it's such a fantastic landscape and a really fun place to be. It can be a really wild landscape and a kind of a formidable one to explore, but I think it's definitely worthwhile. We did talk about how the weather on the valley floor really does change. So when you're going into the Valley of 10,000 Smokes, you got to be prepared. But I wanted to kind of walk you through a little bit of exploring the Valley of 10,000 Smokes itself. So let me go back to the previous screen that I was just on here. Okay. Because when you actually are taking a backcountry trip into the Valley of 10,000 Smokes, you typically don't start right at the visitor center, although you can. There's kind of a route that starts about a half mile before the visitor center, and that takes you down into the Windy Creek Valley. You have to sort of push your way along a foot-maintained trail. This trail is not maintained by the park. It's just maintained by people who happen to be walking along the way, so it can get pretty thick with vegetation. There's you come to Windy Creek, and that's a pretty straightforward stream crossing, not really something that you have to worry too much about when the water levels are normal. And then once you get across Windy Creek, you really enter quickly into the ash flow of the Valley of 10,000 Smokes. You're forced to go up and along the edge of the buttress range because the River Lethe, one of the really violent streams in the Valley of 10,000 Smokes, is impassable for most of its length. So you sort of get funneled up next to the buttress range along the way. And the buttress range is on the very left side of the Valley of 10,000 Smokes. But eventually that footpath that most people happen to follow, it just peters out, just sort of disappears. And you can take a lot of different routes along the way. You can follow the River Lethe for its whole length, and that's kind of a cool hike to do because you get to explore the gorge in detail. And it's not very wide in its upper sections, but it's still impassable. It's maybe only 10 feet wide, but I mean, from the top of the gorge down to the water itself is maybe 15 feet, and there's a huge volume of water flowing through there. It's almost like the river turns on its side. So it's in some of its upper portions, it's broader, and then all of a sudden it sort of just turns from horizontal to vertical, and it just cuts straight down through the ash flow itself. So you can't safely cross the River Lethe in most places. In fact, the most dangerous thing about the River Lethe itself happens to be the stream crossings. It's not bears, it's not necessarily the wind, it's not the chance of another volcanic eruption. And the chances of another volcanic eruption are always there. Certainly they're always there, and that's a question in the Q&A app, so I guess I can answer that right now. Katmai has depending on your definition of an active volcano, Katmai has about 14 active volcanoes. The most recent eruption that happened here in the park was in 2006, and it was a very small eruption, just sort of a footnote, really, in the history of volcanic eruptions in Alaska and within Katmai. But definitely, the potential for another eruption exists. An eruption on the scale of the 1912 eruption here, that is unlikely to happen. An event like that in Alaska happens maybe once every 1,000 years or so. It's not a very common event. An eruption like one of the destinations in the valley that you can actually go to, and let me get to a photograph of that. An eruption on the scale of Mount Trident that happened here from 1953 through 1963. There was a series of eruptions from Mount Trident during that time. That's probably about business as usual, and you can expect an eruption like that to happen quite commonly. So that eruption from in the 1950s and early 1960s wasn't a very explosive eruption. It did have lava flows, but they were very, very slow eruptions. They just sort of oozed across the landscape, and you can see the lobe of one of these eruptions, that very dark material on the horizon at the top of the photograph. That's a lava flow from Trident Volcano. So it was a very blocky lava flow. There was some ash that went up into the atmosphere, but not really a whole lot. So that's kind of business as usual. So the potential for a volcanic eruption certainly is there, and that's why the Alaska Volcano Observatory, their whole basically mission is to study and monitor these volcanoes. So we have, as best we can, some advanced warning of whether or not something is going to erupt. And they monitor volcanoes through seismometers that are stationed throughout the area, because volcanoes, they don't really erupt without warning. When magma is moving underneath the Earth, it's causing earthquakes. So when you see an increase in seismicity, an increase in earthquakes across an area of land, and it's underneath volcanoes, you can probably have a good idea that maybe a volcano is going to become going into a state of unrest. So the Alaska Volcano Observatory monitors the volcanoes to try to give us a good idea of when these volcanoes are going to happen to erupt. So again, you're exploring the river. Exploring the River Lethe is one place that you can actually happen to go. There are a few places that are wide enough to actually cross, where when the water level is low, it's really only about up to your knees or a little bit higher. You still have to be really careful, though, trying to cross these streams. Because if you make a mistake and you get swept downstream and you get swept into one of these gorges, the chances of actually coming out are going to be very, very low for you. So this is a place that I end up crossing occasionally when the water level is low enough, but I am very, very careful to do so only when the water level is low. There have been times where I've looked at that crossing and said, no way, I'm not going through there, because the water level was much, much higher, and to get swept down into that gorge, there's just no way I could fight it, no way I could come back out. So in the valley, that's the most dangerous thing, certainly is the stream crossings. So be cautious if you happen to go out there. But there's many, many places to explore, of course. You can hike up to the base of Mount McGeek, just a spectacular area there to see a glacially fed lake that's clear blue water out there. You can explore the valley to look for the colors in the fumaroles, and I think I was trying to show you some of these before, and of course the screen share didn't end up working, so you just saw my face the whole time. So you can see the kaleidoscopes of colors that the fumaroles happen to actually create. Reds and oranges from, there's sulfur minerals in there, there's iron minerals in there, there are aluminum minerals in there, magnetite as well, silica minerals as well. Many of the white color that you happen to see happens to be redeposited silica. Some of the yellow happens to be redeposited sulfur. The reds and oranges, of course, iron oxides along the way. Blacks, colors where some of these fumaroles happen to be maybe magnetite minerals. Really, really cool stuff that you happen to find. But you do have to be prepared to slog through some pretty tough conditions, and a lot of times hiking through the valley is like hiking through just miles and miles of sand and ash. And again, some of the those fumarole pipes that I wanted to show you earlier. Really, really cool stuff. Really beautiful stuff along the way. You can hike into Katmai Pass, which is where Robert Griggs happened to first discover the valley. Of course, he was coming from the south, and most people hike into the valley from the north to Katmai Pass. But you're hiking through that area, you can try to imagine what it would be like for him to first sight that landscape of thousands of steams coming out of the earth. You can climb to the top of the recent eruption on Trident Volcano, see some of the warm springs at the base of those lava flows. Maybe even go to the Knife Creek glaciers, which are covered with as much as 6 feet of ash itself. And those glaciers, unlike a lot of glaciers in Alaska, haven't receded really since the 1912 eruption because their lower portions are insulated by the ash layer itself. And so the ash is a pretty good insulator, so it just doesn't happen to melt the ice underneath. And of course, I really would recommend exploring Nova Eruption. I gotta sort of, as we get towards the conclusion here of our hangout, I gotta, talk about Nova Eruption because it is the source of the eruption. This is this lava dome is only about 200 feet high, about 1,200 feet in diameter itself, and it sits at the center of a 2-kilometer wide vent, and that's where all of the Valley of 10,000 Smokes, or all of the ash that basically went up into the sky, all of the ash that formed the Valley of 10,000 Smokes, that's where it happened to come from. It happened to come from this vent and not Mount Katmai. When you go there, you can see definitely the power of this landscape and the violence of this landscape with large volcanic bombs that were thrown out of the surface of the earth. This is also one of the areas around Nova Eruption that's the most colorful. And some areas where that was hottest during the eruption, or after the eruption, did have, or does have some of the most advanced vegetative recovery near the head of the valley itself, because the ground tends to be a little warm there with some of the lukewarm steam that's coming out of the earth. It's not superheated anymore, but it's lukewarm, and that tends to melt the snow off. That steam tends to keep the soil moist, and some plants can get established there, like mosses and a few other things. So you can see some more advanced state of recovery in that area. And again, it's one of the more colorful areas that you can actually find. When you're camping in the Valley of 10,000 Smokes, you got to be really careful about the winds, though, and you want to choose a good campsite. Some of the expeditions that Robert Griggs happened to go on, he experienced some really powerful winds, and in fact, he writes a whole chapter in his classic 1922 book about this gigantic windstorm that just destroyed their camp. Where they were camping, there was not a good place. It was out in the middle of the valley, really no shelter at all. And during the middle of the night, this windstorm came in and just destroyed their tents, destroyed their equipment. Robert Griggs reported actually the wind being so strong that it threw him into the air. So pick a good spot when you're out there, and be prepared to protect your eyes if you need to. When the ash is being blown through the air, that's really just fragments of volcanic glass, and it's not good to get into your lungs. It's not good to get into your eyeballs. It can ruin optics as well, so you have to be careful with your cameras if there's a lot of ash being blown through the air. So do be careful of that. And again, you want to realize that the winds are very fierce and can carve rock. So if it can carve rock, it can easily destroy your tent when you're out there. So pick sheltered locations along the margins of the valley. Those are generally the best places to pitch a tent. I found success along the Buttress Range, camping there. Near the McGeek Lakes is a great place to find a sheltered place to pitch your tent. Near Nova Eruption as well, too. Those are all places where I happen to camp, and I happen to find that it's kind of a great spot to camp itself. But again, in this photograph, you can see that piece of pumice that happened to be carved out by the winds. And the prevailing winds in the valley are generally from north to south. They can blow in any or south to north, either direction. They can blow. They tend to blow the strongest though out of the south, because Katmai Pass is one of the low passes in the Aleutian Range, and when you have a strong storm on one side of the Aleutian Range or the other, and you have these different storm systems sort of colliding and interacting with one another, they're going to one's going to try to win over the other. And when you have really strong winds in these storm systems fighting one another, you can have some pretty fierce conditions out in the middle of the valley, and you don't want to be there when that's actually happening. So wind scouring is definitely something to be aware of, and you don't want to camp in a spot like this for sure. All right. So there were a couple more questions that I'm going to answer before I happen to go. I think there's one question on the queue here that I did. Let me get my ugly mug back up here again one more time. And minimize the screen. There I am. Okay. So one more question, and I think I kind of answered this previously, but I forgot to click it in our Q&A app. Are there any animals in the area? Definitely animals use the Valley of 10,000 Smokes, but they don't often use it as a home. It's pretty barren landscape out there, not a lot of vegetation as we talked about before, not a lot of habitat for animals. So you will find in some places, especially in the margins of the valley, ground squirrels, wolverines, ptarmigan as well. Some birds will actually nest at the head of the valley, like snow buntings. They can nest out there. Ptarmigan will nest out there as well. I've even actually seen out in the Valley of 10,000 Smokes, I've even actually seen some semi-palmated plovers. I've seen mallards in the rivers. So you can run into a lot of different stuff out there. Caribou even, and moose use the area. But a lot of the larger mammals, when they're moving through there, they're not using it necessarily as their home because there's just no food really. They're just using it as a travel corridor. So bears will pass through the area, moose will pass through the area, but they happen to be more common on the edges of the valley than anywhere else. So you will find animals out there, but not a whole lot. If you're looking for animals, look on the margins of the valley. You're taking the Valley of 10,000 Smokes tour. Keep your eyes peeled all around the road as you're traveling down the road. Look in the areas where you have good visibility, and you may be able to get lucky and see some of those really big, large animals that we happen to enjoy here in Katmai. So let's see. What's the name of the book that I was talking about? I can look that up for you real quick. So let me share my desktop with you. Okay, so I'm going to go to my web browser here and open a new tab. So you can, in your browser, just type in Valley of 10,000 Smokes and Griggs, 1922 book. Should be one of the first hits that comes up. It's online. It's actually this book's in the public domain right now, and you can find some of the really original copies sometimes used for sale. Here we are. And I have my own copy that I found online just for fairly cheap, a first edition of that. So that was pretty cool for me to actually find. So this is there is an ebook. I must have clicked on the wrong thing. Let's see here. Ebook, Valley of 10,000 Smokes, 1922. Here it is. Let's see. Yeah, so this is it. So if you end up just typing in those search terms, it'll be the first link. And this is a really fantastic book. So it was scanned directly out of the original. So some of the images are a little bit hard to see, but I think this is sort of a classic in adventure travel. Really, really interesting book, and I've read it several times just because I like the valley, and I think this is such a cool tale. So definitely. I'd recommend reading it if you want to get a good idea of the adventures and trials and tribulations of the first explorers coming to this area, and you wanted to get a good idea of why these people were so enamored with the landscape. And also, of course, it has a lot of great insights into how the eruption impacted people in the area too. All right, so. Okay, so will the landscape always stay barren, or could a forest grow there? You know, kind of going back to when we were talking about the vegetation. There will be some vegetation growing there eventually, but it'll take a long time. Again, short growing season, really fierce winds, not you know, any real nutrients in that ash layer itself. Volcanic soils or volcanically derived soils can sometimes be very, very fertile, but they're oftentimes not. And they need to weather for a significant period of time and somehow be mixed with some organic debris before they become fertile. And the ash and the pyroclastic flows that form the Valley of 10,000 Smokes itself just really don't have any nutrients in them. So you're not really going to find a lot of vegetation growing there for such a long period of time, and especially you got those other factors too. You got droughty conditions in the summertime, and you got those winds that just scour the vegetation. You can imagine trying to lay in the Valley of 10,000 Smokes and let, you know, these pieces of pumice get thrown through the air and hitting you. Eventually that's going to start to scour your skin, and it does the same for the vegetation, just destroys it. So you're not going to find a lot of vegetation growing there in the near future, but eventually you probably will find vegetation growing on the margins and starting to creep in the margins of the Valley of 10,000 Smokes. And essentially, I think from the lower elevations at the northern end of the valley going up to the highest elevations, that's how the vegetation is going to progress along the way. And let's see. And this is a question that came in even before the chat started. And can a visitor collect a small, very small sample of ash when they happen to go there? And you can't. I would like to. We can collect things for research purposes and educational purposes. The park can. But to collect anything in the Valley of 10,000 Smokes, you'd have to get a research permit. So if you wanted to grab a piece of ash for yourself, it's not permitted. In fact, collecting anything within Katmai National Park is prohibited. So that's just something to be aware of when you come. We want to make sure that everything is protected for generations in the future. And you look at such a large landscape like the Valley of 10,000 Smokes, 45 square miles of ash, and you think, well, how could anyone really pick over that? But even, especially in the areas where people happen to be frequenting, especially along the Valley of 10,000 Smokes tour, we're finding that some of the more interesting pieces are disappearing. So, you know, we used to be fairly easy to find pieces of banded pumice along the Valley of 10,000 Smokes tour, the hike that you do down to the valley floor itself, but anymore it's getting more and more difficult to find this stuff. So we really need to make sure that we leave everything behind for other people to enjoy in the future. And that's why digital cameras are so great. I take probably thousands of pictures per summer of bears and of rocks and of willows and all sorts of you know, things. So bring your camera along. If it's not, you know, blowing dust, then you can take some really great photos, and I think that's the best way to save your memories. And let's see, I think that I have answered pretty much all of the questions that people had here. So we're going to conclude the Hangout right now, and I'd like to thank everybody for joining me. And I apologize for not having the technology worked out here. You think I would know this, know how to work this stuff by now, but it's a work in progress. We're experimenting here at Katmai. We want to make sure that we you know, bring the park to you as best as possible. We're getting ready for bear cam season here, and I know a lot of you are very excited for that, and I am as well. And we're hoping to get a new cam hooked up soon for everybody. So I'm not going to tell you any more than that, but that's something for everybody to get excited about. And we'll hope to join you soon. Hopefully we're going to join you sometime in April on one of the bear camps, and we'll be chatting then. So again, thanks for joining me, everybody. I apologize for the technical snafu that we had earlier, but enjoy your day. And if you have other questions, I'll probably be on explore.org sometime in the near future to try to answer those for you. So have a good evening, and thanks for listening.